Hello friends, welcome to my radio room. I'm Sean, or as they say on the ham radio bands, my call sign is WB6JWB. I've put together a short video that describes a project I've recently completed. That project involves the over-the-air remote control of an antenna rotator using DTMF commands. Something like this might be useful, for example, if you have a remote base or a repeater or some other remote installation with no internet connectivity, and so a rotator can be spun around to your desire using over-the-air touch-tone controls. Very unique project, obviously, but it was interesting to work through, and the code that is used could be slightly modified for probably any rotator, or for that matter, multiple similar projects. So let's have a look. So the first thing I need to do is make sure there is a voltage output from the rotator controller that correlates to the rotator position. It didn't take long to figure out it does. Soon thereafter, I bought an Arduino Mega 256 board, a relay board, an 8870 DTMF decoder, and a little proto board. I did some initial proof of concept coding, but had to take a long break from the project due to unforeseen circumstances. After a long break, I got back to it, started again by wiring the relays to the rotator controller. 4 relays are used to control the brake, clockwise and counterclockwise controls. Getting back to the code, I finished the DTMF function used to send bearing info over the air. Each bearing starts with a prefix D like delta, and then a 3-digit bearing number, for example, 090 for 90 degrees. The next function was some analog input smoothing code I got from GitHub and modified a little. It's used to smooth the voltage taken from the controller, which can be erratic, especially while the rotator is in motion. Next step was to build a table of if statements, if I can call it that, to convert the input voltage from the controller to display the current heading data on the LCD. I know there are more elegant methods of doing this, but this worked well. Similarly, another table of if statements to convert the DTMF input into the new 3-digit bearing value. And finally, there's a rotator logic to determine whether the rotator should start, stop, turn clockwise or counterclockwise. The code compares the new bearing value to the current heading value to make a choice of what to do. On the surface, the logic would seem simple, such as a basic greater than or less than function. As it happens, it became more complex than that because of hysteresis issues, where the current heading data lags behind the new bearing data. Here you can see an example of 2 values overlapping, making the greater than or less than math not workable. So I built in a buffer of sorts to correct the hysteresis, which worked well as a solution. Here on the LCD screen, you can see from top to bottom the display shows the current heading, the new bearing as received in real time over the air, and then the bearing and heading information is shown in analog values. When these values are approximately the same, the relay is open and the rotator stops. Otherwise, when the new bearing is greater than the current position, the rotator turns clockwise, or the rotator turns counterclockwise when the bearing value is less than the heading. So for this project, I had to have the rotator in the radio room for development of the code. Thanks to my friend Tom, K6QCX, for loaning me the rotator, and it was already on a nice stand that could fit in the shack. Also, I needed a Yagi antenna for testing. And again, just my luck, another friend, Eric, KN6EIV, recently built this amazing 220 megahertz antenna for me that I've been using at my station. So I've temporarily put it here in the shack for the project. You can see how fast and responsive the rotator is to the commands received over the air. Overall, it was a fun project and I learned a lot about coding with the Arduino. This code, with a few changes, could easily be used for any rotator that has a linear voltage output that correlates to the antenna heading. $73 for now. This is WB6JWB.
One more.